Welcome back to the exciting world of hardware architecture. You might be wondering why you should learn about this stuff. You probably won't build any hardware, although it's fun stuff to do, but it's important to know the basics. Plus, it's a great way to impress your friends with all the fancy tech words you'll learn. Do you ever wonder how a computer works? It's crazy to think that something as big as a cabinet in the old days can now fit inside your pocket. How does this happen? Let's explore. First, we're talking about a cute little computer that's taking the tech world by storm, the Raspberry Pi. Isn't it adorable? But don't let its size fool you. This little computer is packed with power. It has everything you need to get started: a main memory, a CPU, and connections for peripherals like keyboards and mice. Now you might be wondering, what about secondary storage? Well, the Raspberry Pi doesn't come with it yet, but don't worry. You can easily plug in a USB to add more storage. As technology advances, we're seeing computers get smaller and smaller, but their architecture stays the same. That's why the Raspberry Pi is such an important tool for coders and makers. It's a glimpse into the future of computing. Before we dive into our next subject, let's take a step back and explore the basic components of a computer. Let's start with the Central Processing Unit, or CPU for short. This little guy runs the program and is always wondering what to do next. It's not exactly the brains of the operation, in fact it's pretty dumb, but it's lightning fast. Next up, we have input devices. These include your trusty keyboard, mouse, and even touch screens. Without these devices, we wouldn't be able to communicate with our computers. On the other end, we have output devices, which include your computer screen, speakers, printers, and even DVD burners. These devices are responsible for giving us the results of our hard work. Now let's talk about main memory, aka RAM. This is fast, small, temporary storage that's lost on reboot. It's where your computer stores data it's currently using, like open applications or browser tabs. Lastly, we have secondary memory, which is slower and larger than main memory. This is where your computer stores permanent data, like your photos, videos, and music. Think disk drives and memory sticks. So there you have it, the basic components of a computer. Understanding these elements is crucial to becoming a master coder. Now we're going to take a closer look at what's inside a computer. The central processor, or CPU, is like the brain of the computer. It's responsible for processing instructions that the computer receives from software programs. But it's not really smart, it's just really fast. That's why we need good software to make up for its lack of intelligence. Let's see how it works. At its core, we have the microprocessing unit, or CPU for short. This little guy acts as the computer's brain, asking, "What do you want me to do next?" 3 billion times a second. As you can see, the CPU receives instructions through tiny pins on the back. It then processes these instructions lightning fast, thanks to its impressive speed. But how does the CPU work? Well, I've created a handy flowchart to explain it all. In this flowchart, the CPU first fetches an instruction from memory. It then decodes the instruction to determine what operation needs to be performed. Next, the CPU executes the operation, producing a result. Finally, the result is stored back in memory and the process starts over again with a new instruction. These instructions are stored in main memory, which is where your program is stored, or a program that came with your hardware. When the CPU needs a new instruction, it asks main memory for it. The memory feeds the instruction to the CPU executes it, and the cycle repeats. The main memory is where all the programs are stored. It's the fast part of the computer that feeds instructions to the CPU. Main memory, also known as RAM, is used for temporary storage of data and instructions that the CPU needs to access quickly. It's faster than secondary memory, but it's also more expensive and has limited capacity. Main memory loses its contents when the computer is turned off. So, for the summarize, the CPU asks for instructions one at a time and stores them in the main memory. The memory feeds the instruction to the CPU executes it, and the cycle repeats. But what happens when you turn off the power? Where are these instructions stored? That's where secondary storage comes in. Secondary storage is like the computer's long-term memory. You can store files like word processing documents or music on it, and they'll stay there even when the power is off. A hard drive is an example of secondary storage, and it's connected to the motherboard along with other components like the CPU and main memory. Secondary memory, on the other hand, is slower than main memory, but it's also cheaper and has much larger capacity. Secondary memory retains its contents even when the computer is turned off. Let's look at a flowchart to understand it better. In this flowchart, the CPU fetches an instruction from memory, decodes it to determine what operation needs to be performed, and executes the operation, producing a result. The result is then stored in main memory. Input-output devices communicate with the main memory to read and write data. For example, when you type on a keyboard, the input device sends the data to the main memory for storage. When you view an image on your screen, the image is sent from the secondary memory to the main memory, and then to the output device, the screen, for display. Secondary memory, such as a disk drive or memory stick, is used for larger, more permanent storage of data. So, to save data, the computer uses a file system to organize and manage the data stored on secondary memory. When you save a file, the data is written to a specific location on the disk, and the file system keeps track of where the data is stored. When you open the file again, the data is read from the disk and loaded into main memory for use by the CPU. These days, secondary storage is usually flash RAM or static RAM with no moving parts. As programmers, it's up to us to create instructions for the CPU to execute. We write these instructions in programming languages and store them in the main memory of the computer. However, to ensure that our code is not lost, we store it on secondary memory, such as a hard drive or USB stick. Now that you know the basics, you'll be able to impress your friends with terms like CPU, main memory, and secondary storage. And if you want to go even deeper, there are lots of other hardware components to explore. So now you know the basics of how the CPU, main memory, and secondary storage work together to make your computer function. If you want to learn even more about computer hardware, be sure to subscribe to our channel and hit the notification bell. Thanks for watching.